All right, so this is problem 21, the magnetic fields. So the question is asking, consider two current carrying wires separated by a distance of 4.2 centimeters as shown in the figure above, right? The left wire is directed out of the page, so out of the page, and the right wire is directed into the page, so with the current I2. The point P is a distance D from the wire, so the wires and the point form an equilateral triangle. So the first question is, if both wires are carrying a current of 5.5 amps, what is the magnitude of the magnetic field in Teslas at point P? So for this question, since they're both carrying they're both carrying the same current, then it's just going to be, and they're at the same distance away, so it's just going to be a simple, using the magnetic field equation, the mu naught current divided by 2 pi d. And so the answer there should be 2.6 times 10 to the negative fifth Teslas. And then for part B, the question is, if the current from the first wire is 5.5 amps and the current from the second is 11 amps, what is the magnitude of the magnetic field at point B? So now it's a bit different because it involves different currents, and based off of that, we're going to need to have to split this into two dimensions, an x and a y component, as like vector quantities, as the magnetic field will push in the x and y direction. So first I calculated the y component, so I did the same thing except switched the current for the second one and added sine 30. So then I got these two values for b1y and b2y, which I then added together to get our net magnetic field in the y direction. Next, I found the horizontal component. This is negative because of the going into the field. And so I did cosine 30 here, and then the same thing, and then I added them together, and I got 2.27 times 10 to the negative fifth Teslas. So then, yeah, added together 2.27. So then, for our net magnetic field, I took the resulting vector by squaring the two and finding the resultant vectors, which is 4.4 times 10 to the negative fifth Teslas, which is the answer here. And this is the diagram into the page, out of the page into the page, and all towards that point P. So cosine, since it's an equilateral triangle, it's going to have 30 degrees, 60, but split in half, 30, 30. So that's why I used sine 30 and cosine 30, because it's going this way, it's going that way too.